Good morning, all. I will start this off by just setting the stage for Kathy's presentation shortly. It's the intersection of people, policy, sustainability, and technology. And from the conversations we've already had this morning, we can't think of this, for Kathy, yeah, thank you. We've gotten beyond the point where we can think of industries as silos. And as we talk through this in a few minutes after Kathy's conversation, I want us to keep in mind that regions, cities, industries, for the most part regions, are tied together by three things. Technology, as we all know, transportation of people and resources, and the energy used to transport those resources, in some cases water, for our conversations this morning, water, and policy. The combination of those three things tend to lead to the culture of how we approach the power and the water we use. And we'll frame that as the conversation goes on this morning. So Kathy, please come up.
All right. Good morning, everyone. Thank you so much for the invitation to be here. Really a pleasure. My name is Catherine Sandoval. I'm a law professor at Santa Clara University and had the honor of serving a 6-year term as a commissioner of the California Public Utilities Commission. So I wanted to recognize I'm joined today by Jamie Ormond, who's with the California Public Utilities Commission. She was my water and legal advisor when I served as a commissioner, and really did yeoman's work, continues to do tremendous work on renewable energy at the commission, and she's also my former law student. So really, there are a lot of things that we accomplished that I could not have accomplished without Jamie. So just wanted to speak really quickly about a few issues with regard to the Water Energy Nexus, and really appreciate the title of this presentation and this panel where we're talking about the intersection of people, policy, sustainability, and technology. And that this also puts people first and at the center, which I think is sadly something that is too often forgotten. And when we talk about how do we bring these together, some of these issues also have to do with realigning regulatory paradigms and thinking outside of different silos, including technology silos, regulatory silos, policy silos. So I wanted to really focus on two projects that we worked on at the PUC and where I think there are still ongoing opportunities. So the first comes out of the Water Energy Nexus proceeding that I had the honor of leading at the California Public Utilities Commission. So it was a proceeding that looked at the embedded energy in water, and the embedded water and energy, and what we could do to reduce both, particularly in light of California's drought. At the time that we were working on this, California was on the 6-year drought. And so it really became urgent for us to look at how we could conserve water, as well as we dealt with issues like in Los Angeles, the outage of the Aliso Canyon natural gas storage field meant that suddenly in Los Angeles, the second largest city in America, we were short on natural gas. And there was a real concern that there wasn't going to be enough natural gas to support power plants. So saving water and energy became critical. And one of the things that we identified was things like leaky hot water heaters. And especially where you have hot water heaters that are actually leaking and running 24 hours a day, they are drawing both water and natural gas. So these were all things that were not good in terms of those situations. So in terms of figuring out how do we address this, one of the things that we looked at as well is using technology, including telecommunications, to help to address these issues. So I teach energy law, communications law, contracts, and antitrust law, and also had worked at the Federal Communications Commission for several years and have worked in the communications industry. So I've been aware of what we could do as we really were able to apply communications and information technology to water and energy and bring those together. So what we looked at and were able to begin through the Water Energy Nexus proceeding is to leverage the massive investment that this state and our nation has made in the smart meter infrastructure and really the smart communications infrastructure for energy, and to leverage that for water. And so part of what we authorized and designed, and I really wanted to thank Jamie Ormond for her help in designing this project, was a series of AMI, or automated meter infrastructure pilots. We call them the piggybacking pilots, where you could have the water utilities in a local area piggyback on the meter infrastructure of the energy utilities, both natural gas and electricity. So this picture gives you a sense of what some of the networks are like in a neighborhood, the collectors that we wanted to be able to connect together. And then this would allow things like quickly identifying abnormally high usage, but also identifying things such as methane leaks. And as they began these pilots, they realized that it was a real opportunity as well to work with pipeline companies, natural gas pipeline companies and pipeline facilities to identify methane leaks, which can become hazardous and also are a big air pollutant. And so these are some of the preliminary results that came from this pilot. So we quickly had, the pilot was authorized in mid-2016 and really started getting underway by the end of 2016. So within a year, they had flagged over 314 leaks, saved over 10 million gallons of water, saved 64,000 and change embedded energy, kilowatts of energy, and avoided about 27,000 in CO2, and then also saved substantially in electricity costs. So there are some real results from this. We're still waiting for the 2018 reports from some of the companies, but one of the things that we did is that we did build in evaluation. So I think this really demonstrates some of the possibilities as you connect the infrastructure to leverage the infrastructure across utilities. And part of, before I go on to this next part of what I wanted to underscore, so I'm not sure how I go back, there we go. Part of what I wanted to underscore is that the way we're able to do this is through the regulatory alignment. It started with what we did, the first thing we did in the Water Energy Nexus proceeding was develop a cost calculator that allows the calculation of the embedded energy in water. And so this allowed us then to basically incentivize energy utilities to save water and thus to get credit in energy efficiency programs for measures that saved water. So once we did that, then that's what opened up this smart meter network, because then the smart meter network, this became a ratepayer function where they would then be saving energy by helping to save water. So it was about the regulatory alignment that then allowed the technological alignment and leverage. So then last I wanted to close with this and open up to our dialogue, and the next speaker we look forward to hearing from. When we talk about connecting people and policy, and I thought following up on the previous two presentations where we talk about the places in the world that lack energy, we heard as well about places in Texas lacking water, but a lot of people don't realize that here in California, there are people who want electricity who don't have it. And I recently wrote a book chapter on the Native American reservation electricity gap, the people in the continental United States who most lack access to electricity are Native Americans living on reservations. And because electricity, water, and communications are interconnected infrastructure, this has a huge impact as well on water resources and access to clean water, as well as on communications. So here in California, we have 109 federally recognized tribes. And so one of the things that we also did to connect people and policy is I had the honor of being the assigned commissioner for the Energy Savings Assistance Program, in which one of the things that we did was also direct the electric and gas utilities as well to work at the Water Energy Nexus and to engage in some of these water saving measures using the cost calculator to save the embedded energy in water. But we also ordered the investor-owned utilities to consult with the tribes that they serve, the federally recognized tribes in their service areas. And so between PG&E, Edison, San Diego Gas and Electric, and SoCal Gas, they serve 101 of the 109 federally recognized tribes in California. So PG&E said that it would prioritize tribes according to a variety of factors, including poverty levels, low levels of energy savings assistance treatment, as well as the existence of utility connections, which is important. So this is a picture of the Yurok Reservation. It's in Northern California on the Klamath River, about 6 hours north of here. Jamie has been there with me. So the top picture is one from the Tribal Planning Director, from Peggy O'Neill, when actually the Army Corps of Engineers was helping to build electricity to the Yurok Reservation. This picture was taken in 2013. And you see at the bottom a picture that was taken in 2018 as they were finishing the build out to provide for the first time electricity to the elementary school, State of California Elementary School on the Yurok Reservation, that got electricity in August of 2018. And until that point, they had been running on diesel generators. This project also allowed their water system to get electricity for the facility in that area, as well as brought electricity to the community. And you see on the bottom the new pole on the left, and what's leaning here is actually a tree. And a hydro system had been using that, but it was a very spiky hydro system. So this is how PG&E has prioritized in terms of those criteria. And so the number one priority for the energy efficiency consultation and treatment is the Yurok Reservation. So this is the Jack Norton Elementary School, which ran on diesel generators until August and just got connected to electricity. We also got them, backup generators are now natural gas. It's a 2-room schoolhouse, so these are some of the super cute children in the younger class. And we met with the children. I went back there in November after doing a presentation with the Yurok tribe, and then went up there with some people from PG&E to talk about coordination on water and energy. And we asked the students what they thought about now having electricity at the school. And one of the students said, "Now I can hear the forest." And another student said, "Now I can hear myself think." Because also the generators were really noisy. I have it on my phone. We measured them at machine shop levels, as well as the pollution is incredibly harmful to human health. And then we also know now that the pollutants from diesel are actually really harmful in terms of climate change and snowmelt. But when we ask them about what are your conditions like at home, both of the teachers still lack access to electricity at home, and about half of the students still lack access to electricity at home. And some of these students are still reading at night by kerosene. I stress that these people are in Northern California, and they go to, this is a State of California school. So Manoj, we should talk about your the product that you have, because they have tried solar, and in their beautiful, heavily forested location, where you often get fog coming up from the trees as well as down, and there's a lot of forest fires in that area, solar has been very ineffective, which is why the tribe has studied things and decided to focus on grid electricity as a way to help to bring these resources that were necessary, because they recognize that having access to electricity is going to be key to actually safe drinking water. They've been on a boiled water alert for some time, and so when you're on a boiled water alert and you don't have electricity, people are spending huge amounts of money and time using propane tanks in order to boil water. So it is very costly as well as potentially dangerous. So in closing, I wanted to emphasize, as we talk about people, and when we're talking about Native American tribes, that tribal consultation is key. We did a lot of work with the Public Utilities Commission, and again, I want to thank Jamie, who's also with me in this picture, as well as our whole team, and the PUC has continued and is developing a formal tribal consultation policy. I'm also on the board of the American Indian Chamber of Commerce, and I'd like to stress, I'm a Latina from Los Angeles. enormous. But these are things that we all need to do because they are Californians, and the idea that children in California do not have electricity and are reading by kerosene is something that all of us need to take action about. And so when we met with the tribal chairman, one of the things that the chairman said was, our people are known for our dances and our ability to talk to the spirits and the star people and the sun people, but we really want to talk on the internet. And he also recognizes that the internet would make a huge difference for their water system as well. And he was just recovering from E. coli that had happened because of the lack of detection for the water system. So engaging people to develop policy and promote sustainability and to connect the people with the technology, right? They want they recognize that these technologies are going to be necessary for their tribe, which has existed for millennia. They are California's largest tribe. There are more than 6,000 of them, to not only exist in this millennia, but to thrive for this millennia and beyond. So thank you very much, and I look forward to our discussion.
I'll bring Michael up stage as well. And I'll tie the point you just made, Kathy, to the question I'll ask Michael. And before you answer the question, I'd love you to share your background. My company, Varuna, we provide insights to the water utility between the wastewater treatment plant and the home, the quality and operational efficiency through hardware and software. And we're starting a pilot with Detroit because of what has been sort of a lack of economic power in some parts of Detroit to allow them to make better decisions about the infrastructure they have in those regions, and decisions by policymakers that haven't really helped them. Michael, please share your background and also tie that to some of the fascinating economic innovations that you're seeing, enabling us to start to address these problems in areas we probably couldn't do so before.
Yeah, sure. I appreciate the opportunity to speak with you and look forward to discussing afterwards. So I've been working on public-private partnerships, so infrastructure, energy extractives, natural resources for about 20 years, advised international organizations, governments, as well as in the US, the federal, state, and local governments, and then public authorities. I think it might be useful to say a little bit about the financing, and then give one example of what I see as one opportunity tied to the financing component. But when I talk about financing, I think I want to just say something about the challenges of introducing technological solutions that are people-centric into the US government environment and the finance environment, the contracting environment. Because I think that that's the fundamental issue, one of the fundamental issues as we try to have the US be a test bed for innovative approaches to infrastructure. So over the last, I'd say 10 years or so in the US, but mainly the last 4 or 5, there's been a move away from government contracting. So government doesn't do much in the terms of infrastructure these days. Most is contracted out to private sector companies. So there's not so much that's in the government's hands, which shifted, which in the 1980s, there was a lot more, as primarily government did most of the things that it does with regard to infrastructure. So why does government introduce innovative things into its infrastructure? So I think that's a fundamental question because it's a precondition to thinking about the US as a place to effectuate that transformation. 2 reasons. One, off-balance sheet financing. So essentially, governments are, by and large, reaching their debt caps or want to use their money for social services and for human services. So as a result, if you do infrastructure, which was once done with bonding, taxation, if you start to bring in private participation in the form of private equity, you move your liabilities off your balance sheet. So you can do stuff without accounting for it, in terms of financially at least. That's one reason. The second reason, and I think this is also relevant to this group, is that infrastructure is largely balkanized in the US. So you contract out to one group to finance, one group out to build something or design it, one to build, one to operate and maintain. So there's a balkanized system for various reasons throughout the country. So what P3s do, or public-private partnerships do, is they consolidate the process. So the same company designs, builds, operates, and maintains, or at least a general contractor in the private sector rather than the government is overseeing the various companies that do these things. So that raises, I think, and I'm going to talk about it in a rural context again, that raises a fundamental challenge, I think, for technological introduction into the U.S. First, and probably most importantly, is this balkanization. This balkanization has created a situation where there's very little operating and maintaining of infrastructure in the country. We built the stuff 20 years ago often. We run it into the ground largely, not because public sector workers haven't been able to do it, but because we just underfinance it at the end of the day. So I work with a group, I'll give an example, of 36 rural counties in California. They're Joint Powers Authority, and the Joint Powers Authority in California is a government entity. It's just made up of counties. This one's 36, but its membership is 58 counties. So it's largely the state. And the water needs in these counties is extreme, and I'd say for two reasons, and then I want to wrap it up so we have some questions and discussion. But I think primarily for two reasons. One is that there's a lack of financing, and then a lack of available capital to do projects. And then second, a lot of the needs are, at this point, are dominated by operate and maintain needs. So old piping systems that we would think about in an urban environment as being repaired in a precondition to getting things done. And as a result of same thing's true with energy systems, water systems, and communication systems. And because that's the case, what's impeded, and I think this is the opportunity more broadly, and I think to use these counties, for instance, as a test bed for a lot of the technological innovations, and the counties aren't any different than urban communities in the U.S. So, for instance, San Francisco has 12% of San Francisco is not hooked up. But in rural California, it's the size of 10% of the population, it's the 23rd largest state in population. So it's the size of South Carolina, right? Balkanized population-wise, and some of the rural counties are relatively affluent counties as well, but are pockets. So there's two needs. One is some of the last mile household needs that we've been talking about. But the other need that's, I think, equally, if not more pronounced in the counties is an inability to engage in industrial level economic activity. So in other words, so we're in the process of modernizing old mill facilities to do more modern things with them. But you need plentiful water to do it, just like you need plentiful communications and power for the systems. So one of the fundamental questions is, two of the fundamental questions then. One is, how do you introduce technological solutions in this context so we just don't make the piping system so important? So we have different ways of carrying out that at a corporate level. And then second, how to create an oversupply water and energy into counties, because oversupplying is an essential part of America leveraging for growth, opportunity, and those are two fundamental challenges that I think occur particularly outside of urban environments, because in urban environments it's very difficult to introduce industrial level economic activity. You're really feeding into other types of economic activity is often the goal.
So thanks so much for sharing that. As we've seen sort of this transition you're suggesting, and we're all suggesting needs to happen, we've seen that happen a bit more on the power side than on the water side. Some of I'd suggest the approaches to determining policy that has helped the electricity side was to show the economic value along with the sustainability benefits of things like solar, the jobs created, the possibilities that exist on the back of moving away from this centralized approach to distribution on the power side. What examples do you see, and what can be borrowed from that power industry approach on the water side? Because it is lagging behind, and the power side relies a fair bit on the capabilities of the water industry right now. So any thoughts about that?
Yeah, sure.
So I think, as we said, recognizing the interconnectedness of these infrastructures is important, and leveraging. So they have had, on the Yurok Reservation, for example, a small water system for a number of years, and they have a few water treatment facilities. But it's been a real problem since where they are, they don't have cell phone access. So there are some places where in 2014 they got telephone access. I know that there's one site where the tribe has been able to set up some telemetry. This other site, which is near the school, really didn't have good telemetry, and so they were running as well on diesel generators. So connecting the electricity is going to make it much more efficient to be able to run the water facility, and also make it much more attractive to bring in the communications infrastructure, because what they've recognized is that they also need a high level of reliability, and that also with a lot of the renewable resources, or even on diesel, that you end up with this up and down energy that doesn't provide the reliability that you need, for example, for safe drinking water. But they also recognize that they had to engage in really 20 years of leadership to get the financing through the Rural Utility Service and others. They had some financing from the PUC and a settlement from a long time ago, because they felt that building the grid would really create the backbone for a lot of what they needed to do. But now they're looking at, all right, the people who don't live on the road, where to get then to a particular household, if you have to build a grid, it's going to cost $1 million to go to one household. So that's the next challenge. How do you finance that? And then recognizing that the households as well, they have needs in terms of they have septic systems. In some cases, they're able to pipe water, but still you've got to make sure that you're treating the centralized water. It's a real challenge in places like this. And we're all taught in America that the Rural Electrification Administration solved everything in the 1930s through 50s, and it didn't. Native American reservations were not eligible for the grants and loans, and this is part of why they got skipped.
Okay, yeah, I agree the interconnection is essential, particularly in these communities. I'd say another thing, what I see as a challenge, and then what I see as an opportunity here. So a challenge and why energy and water why energy's outpaced water in this country, throughout the country. But I'd say, and because we're devoting some time to Native American tribes and to rural areas, say something about that. So the challenge is in energy. Energy is a private sector activity in the U.S., right? So at its core, for historical reasons, we do energy by and large with the private. It's a squarely private domain. Think of oil and gas, where you don't need anything but a licensing permission usually to do what you want. On the other hand, water is a public sector activity. So you have to understand how to access government in order to do water. Fundamentally different, with the exception of the mountain states where you've, again, got fracking and such supplied by the private sector. And you tend to see water in the private sector with fracking do a whole lot better than water in when it's in the public sector. So that's like a clear example. In terms of somewhere else that it's worked that might be a model, if we think about Penang, we think about places in India where, let's take India, when Intel got regulated out of the U.S., out of California because of environmental issues, folks went to India. Intel went to India. Intel was able to go to India because chip fabrication is a water-intensive industry, right? You can't do chip fabrication with that. What they did is they built a bunch of water capabilities, and then they were able to anchor Intel in southern India and in other places. So that's a story again, the need to do industrial scale solutions in places that have been largely neglected for the last 25 years, but there's a legacy. Otherwise, we wouldn't have highway systems like Route 5 and all these highway systems in California. They were there for timber industry, right? So it hasn't been that long since the 90s, right? So, but there has to be an industrial level as well as a household level. I think that's the opportunity. It's a tremendous place. Those of us who have a lot of international experience, think about international experience as been a tremendous test bed for technological solutions. I'd say these areas of the US are a tremendous test bed for technological solutions, particularly as the cost of labor, the cost of shipping has gone up overseas, and the openness of economic development in rural areas has gone up. There's a need to insource again. So this is where you insource. You insource in rural areas, Native American populations, areas that are on the outskirts of suburban areas, et cetera, et cetera. I think that that's the opportunity as I see it.
Yes, we could go on. Unfortunately, we're out of time, but thank you so much for the time. Please help me.
Thank you very much.
Thanks so much.
Thank you very much. Thank you.